All right, Algebra 3, this is our Chapter 6, Section 1 lesson, and this is kind of a big one actually, and the pre-test that I had already given you in class, it is all about pretty much all of this stuff that we are learning in Section 1. Um, but this isn't going to be a long video, so just bear with me on this video in case it does get long. So let's go ahead and get started. All right, the first thing that we're going to learn about in this section and chapter is something called rational expressions. A rational expression is going to be expressed in this form right here, a p over q, where both values of p and q are polynomials. And then right here, something that y'all were asking about on the test, the first three problems dealt with this. Our value of q, the denominator, cannot equal 0, or else your expression is undefined. And we don't deal with undefined expressions. So here are some examples here. This expression right here is fraction. It's also considered a rational expression, just no variables or anything in it. The denominator is not 0, it's 5. Okay, so 4 over 5, we're good. On this expression here, we have x minus 3 over x. Well, x right here cannot equal 0, sorry. So in this case right here, when stating values that we are going to exclude as a solution to our equation or expressions or something like that, or finding the domain of our expression, we are going to, let's see, get my pen tool. We are going to exclude any value of x that makes the denominator, any value of our variables, that makes the denominator 0. So in this case, all real numbers of x are going to work except where x is equal to 0. And so I'm going to say x cannot equal 0. Okay, let's look at this expression over here, a squared plus 2a over a minus 9. Again, this denominator cannot equal 0. So what you do to find the value that you do not want a to be, you do not want a to make that denominator equal to 0, just set up your denominator, set it equal to 0, and solve. So here, a equals 9, and that's the value you want to exclude from the denominator. A cannot equal 9, okay? And also a minus 9 cannot equal 0. All right, this next one right here, we have z cubed minus 5. Well, in this one, again, do the same thing. Take that denominator. It cannot equal 0. Solve for z. So in this expression, we're going to get hold on for just a second. Well, it does equal that, but we are going to take the cube root of both sides of the equation. So z is equal to cube root of 5. Okay, and so for the value of cube root of 5, z cannot equal that value, or else the denominator is 0. So whenever a rational expression contains a variable in the denominator, assume that the values that make the denominator 0 are excluded. So that's what we are finding by setting it equal to 0 and solving for our variable. We're finding the values that are excluded. Okay, let's move on. Okay, so in a fraction, let's look at down here. Your numerator can be negative, and your denominator can be negative. It doesn't matter where that negative happens. If you have a negative a over b, it's the same thing as a over negative b, because these two both equal negative a over b. If you do have two negatives, like negative a over negative b, let's say that. Let's say we had negative a over negative b. This right here would end up being positive. Kind of like the fact that you multiply two negatives together, it becomes a positive number. Same with division. You divide two negatives, it becomes a positive. Okay, in this slide, I'm going to show you how to simplify a rational expression. So what a simplified rational expression is reducing it to the lowest terms, okay? So when the numerator and the denominator have no common factors other than 1, then it is in simplified or reduced form. Okay, so let's look at this first one. This is just a fraction, and we can reduce this fraction. And I'm going to show you first by just splitting it up into its factors. So 9 can be completely factored into 3 times 3. Well, 24 also has a factor of 3, and the rest of it is 8. 3 times 8 is 24. Okay, well, whenever you have factors that are multiplied together like this, we can start canceling out. So this right here can cancel out with this 3, and we are left with the reduced form of this fraction, which is 3 over 8. And that's exactly how we're going to do the rest of our rational expressions. We're going to break it out into its factors and cancel the factors out that are in common with the numerator and the denominator. So the numerator on this expression, well, we can factor out a y. There's a y here in this term, and then there's a y. There's two y's in this term. So factor out a single y, and what you have left over after factoring out a y is x minus y. Okay, and that's divided by 3y. Now see, we have a y in the numerator, we have y in the denominator. These 3 and y are factors that are being multiplied. Just like I could cancel a 3 from both numerator and denominator here, I can cancel out I'm going to do it in a different color, a y. So our expression that we have now, after canceling out the y, is x minus y over 3. And we're done with that one. Okay, so here are the steps pretty much that we just followed in the last example. But this is how to simplify a rational expression. So factor both the numerator, there's my pen, there it is. Factor both the numerator and the denominator as completely as possible. So once you get it all broken down into its complete factored form, then divide out any factors common to both the numerator and denominator. So let's do that with this expression here. Again, the greatest common factor in the numerator is y. So let's factor out a y. So taking out a y, we are left with x squared y minus 2x plus 3. And then that is still all over y. Now, the second step, it says to cancel out or divide out any factors common to both the numerator and denominator. So y is in common with the numerator and denominator. Those cancel, and you end up getting what's left over. Whenever you cancel out a term, this is very important to remember. What is left over is 1, because 1 times y is just y. Okay, so when you cancel out a y or you're a factor, you're not canceling it to be 0. It is going to be 1. Okay, so what you have here is what's in parentheses right here over 1, or you can just write what is in parentheses, because anything divided by 1 is just what is in the numerator. Okay, so this is equal to your x squared y minus 2x plus 3, and you're done. Okay, so this slide right here is about factoring a negative 1. This is a possible thing that you will have to do in your homework and other material that we go over, is factoring out a negative 1, so we can completely factor out and reduce the rational expression as much as possible. So here is a small example right here of factoring out a negative. So say I want to factor out a negative 1 from this expression right here, negative 2x plus 5. What it's going to equal is negative 1, and in parentheses what you have left over is, well, the negative 2x becomes positive 2x. The positive 5 here becomes negative. So what that equals is negative 2x minus 5 in parentheses. All right, so this right here, this expression that I'm asking you to simplify, it requires us to factor out a negative, the one in the denominator. Okay, but first, let's factor the numerator. And the greatest common factor in the numerator is 2. So let's take out a 2. Okay, factor out 2. And what we're left over is 4a minus 3. Okay, now in this denominator, if I were to factor out a negative, see how this expression inside the this parentheses in the numerator is 4a minus 3? That is so close to 3 minus 4a if we just flip these things around. Okay, I'm going to do that. Change them around. Now, can you see how if I take out a negative, just like this example did up here, I would end up with inside parentheses 4a minus 3. Let's do that. So 2 times the 4a minus 3 over, now factoring out a negative, I'm going to say negative 1, gives us 4a minus 3. Now these two, the numerator and the denominator, have this 4a minus 3 in common, so we can say, let's cancel that out. And what we are left with is 2 over negative 1, or this, what this really equals is negative 2. And we're done. All right, let's go on. Okay, in your homework, after you've basically mastered, hopefully, simplifying rational expressions, we're going to come to multiplying two fractions, or multiplying two rational expressions. Whenever multiplying fractions, like you have here, a over b times c over d, you just multiply straight across, okay? Some people mistake this for doing cross multiplication. Remember, cross multiplication only happens whenever we have something like this, when we have a rational expression or a fraction set equal to another expression. This right here multiplication is called cross multiplication, okay? When you get AD equals BC. This is not what we are doing in this case. We are multiplying fractions, and multiplying, we just multiply numerator to numerator, and then denominator to denominator, okay? So when we do that, we get A times C over B times D. That's it. And then you're never going to have, a 0 in the denominator. So B cannot equal to Z, it cannot equal 0, and D cannot either. All right, so let's multiply this expression together. So I have, well, one thing I'm going to do here is I'm actually going to break it down into its factors first because I know 21 has a factor of 3. So let's go ahead and do that. Oh, I said I was going to break it down. Let's do that now. 3 times 7 is 21. Okay. This right here, I don't know why I wrote down 21. You knew what I meant, right? It's 7. Okay, so 7 here. Now, our 3's are going to cancel out. Those are going to be in common, the numerator denominator here. Now, again, just multiply straight across. Here, like I said before, you do not get a 0 in the numerator. You get a 1 whenever you cancel out something. So, negative 5 times 1 is just negative 5. 7 times 4 will give you 28. So, there you go. Negative 5 over 28 is your answer. So similar how you multiply fractions together, you can multiply rational expressions. So here are the steps on multiplying rational expressions. First, factor all numerators and denominators completely. So just like simplifying a rational expression, that's the first step. Factoring, that's the key thing here. That's why in the previous chapter, we factored a lot. All right, so factor, then divide out common factors, and then multiply the numerator together, and then multiply the denominators together, and you're done. So on this example that I have, let's do this one now. We have negative 18 x squared, y squared, no y, just y, over 11 z times, okay, I noticed here this is 11 and 22 has factors of 2 and 11. So I'm going to go ahead and factor that out. And then we can start canceling things once I'm done. Okay. Now there's no factors of 18 that are in common with any of these numbers here. So that are in the denominator then for that expression. Okay. But when we go to x squared, there is also an x squared over here in this denominator. So x squared from the numerator cancels out with x squared in the denominator over here. And now also we have a y. We have a y. It's considered y to the first. So y to the first completely cancels out with one of the y's from this denominator here. So I'm going to cross out a 5 and make that a 4. Whoops, cross that out. And then same thing goes with, let's look at this denominator over here. 11, cancel that out. And now we have a z also. this z exactly the same as y. It is to the first. So this z to the first is going to completely cancel out with one of the z's here. So I'm going to reduce the power by 1. Okay, once you get done with simplifying and dividing out like factors, multiply straight across. So what do we have left over? Negative 18, that's crossed out, and so is that, times 2. So that's going to give us 36. Well, negative, sorry. Negative 36. And then z squared. Okay, and that's divided by multiplying straight across again. This all became 1 because everything canceled out there. And then x squared is canceled. Y to the 4th is not though, so let's write y to the 4th. And that's it. We're done. All right, guys, before we begin looking at this one, what I need you to do on your handout is correct this if it isn't like this right here. It must read x squared plus 7x minus 18, not plus 12. Okay, so once you do that, let's get started on this one. The first step in multiplying rational expressions is we need to factor out the numerators and denominators completely. This right here, the 1 over the x squared plus 7 minus 18 can be factored out into, so you're looking for two factors of negative 18 that add up to 7, and that is going to be positive 9 and negative 2. Okay. Now on the next part, the next expression that we're multiplying this one to, the numerator can be factored out. So what this will factor out to, see we're looking for two factors of 30 that add up to negative 17. That's supposed to be an x. Okay, so you get x minus 2 and x minus 15. And 2 is just a single number, don't have any factors of that. Now, at this step, after you get done factoring, cancel out anything in common in the numerator and denominator. So x minus 2 is in common with the numerator up here. So x minus 2, x minus 2. Cancel those things out. So now your expression is equal to, multiply straight across 1 times the x minus 15, which is just x minus 15. And then put that over the x plus 9 times 2. And this 2 will distribute across. You can go ahead and do that in this step. Say 2 times, here, I can just go ahead and make another step. So you can say 2 times x plus 9. Now you can leave it in this form right here. I'm totally fine with that, unless I say to multiply the factors out. If you want to multiply the factors out, then do that. Otherwise, don't if I don't say so. Okay, so to x plus 18. And you're done. Okay, I'm going to look at this expression again one more time up here. The first step in this thing does say factor the expressions out in the numerator and denominator completely, okay? Because we must have factors that are being multiplied together. See, this 1 is multiplied to this, and this is multiplied to that. Just like the first fraction that I had was 9 over 24. we split that out into factors. 3 times 3 and 3 times 8. We can only cancel out factors that are in common in the numerator and denominator to get our actual expression in reduced form. Okay, this is why you cannot go straight in and say, okay, I'm just going to cancel out this x squared because it's in common with this x squared. No, that is mistaken. You are very mistaken. Do not do that, okay? I want to warn you now, don't do this. What you need to do is factor first, like we did. Factor it out and cancel out the factors. X squared is not a factor of this expression. It's a term in this expression, but it's not a factor because we are adding it to the next term and then subtracting it from another term. Whenever things are not being multiplied together, you have addition and subtraction. It doesn't mean that x squared is a factor. X squared is not a factor in that one. What is a factor are these right here, what you factor the expression out to be. So please do not make that mistake. I'm warning you now. All right, so let's move on. Now, dividing two fractions is very similar to multiplying. The only thing is you have one step beforehand. Whenever you divide two expressions, this second expression, or fraction in this case, you do the reciprocal. So what you're doing is you're multiplying the reciprocal, meaning reciprocal is interchange these values right here. So flip this, the numerator and denominator, and multiply. So a over b divided by c over d is the same thing as a over b times d over c. And once you're done doing this step and flipping the second fraction or expression, you multiply straight across. So let's do that with this one. It says divide these two fractions. So dividing, you multiply by the reciprocal of the second expression. Now multiply straight across, but remember, first you can cancel out common factors in the numerator and denominator. So here we go. We can cancel out a 9 and we get negative 2 fifths, and we're done. All right, so we're almost done with this. This is pretty much the same as the multiplication one. What I did was, it's the same factorings that we had in the previous multiplying expression like this one. So we should be able to go ahead and factor those out. But before we do, first thing is invert the divisor, the second fraction. So this right here, do the reciprocal of that. So switch the 1 and the x squared minus 17x plus 30. Flip those around. And then we'll start factoring. Okay, so we have x squared plus 7x minus 18. And multiplying that to, we're flipping it, remember, so x squared minus 17x plus 30 all over just 1. So now you should already know the factors that this breaks down into. This breaks down into x plus 9 and x minus 2. And the second expression, the numerator factors out 2. X minus 2 and x minus 15. Once we have those factored, start canceling what's in common in the numerator and denominator, like these two factors, and then multiply straight across. So 1 times the x minus 15, which is just x minus 15, and then the x plus 9 times 1, which is just x plus 9. And we are done. And that also concludes this video. I hope you understood everything, and if you're not, then we will cover some of your questions in class when I see you next. So goodbye, everybody.